Some students burned magnesium and excess oxygen, and produced magnesium oxide right here. Here's their data table from their lab. They had a weigh boat that weighed this much. Then the weigh boat and the magnesium together weighed this much. And then the weigh boat and the magnesium oxide after the reaction weighed this much. The question is, what is the percent yield of the magnesium oxide in this reaction? So there are several steps to solve this problem. The first one is, what is this mass of magnesium? And in order to find that mass, I'm going to subtract these two values, 16.09 minus 14.57, and that's going to give me this number, 1.52 grams. Next, I want to find out, so that's this, equals 1.52 grams magnesium. That's my starting amount of magnesium. Next, what is my actual yield of magnesium oxide? And so to figure that out, I'm going to subtract the weigh boat from this number right here. And so that's going to be 18.24 minus the weigh boat, 14.57, and that equals 3.67 grams. And so that's my actual yield of magnesium oxide, 3.67 grams. Okay, so far I subtracted the weigh boat out in order to get the mass of magnesium, and then I subtracted the weigh boat out of here in order to get the actual yield of the magnesium oxide. So those are these two values here in the data table. Next, in order to get a percent yield, we need two things. We need the actual yield, which we have right here, but we also need a theoretical yield. And to get a theoretical yield, we have to do a calculation to calculate this with some stoichiometry. So, in order to figure it out, I'm going to use this mass of magnesium in order to calculate the theoretical yield. So, 1.52 grams of magnesium times, draw a line. I'm going to bring down the grams, go to the periodic table to find the mass of magnesium, which is here, 24.305, and that is equal to 1 mole of magnesium. Now I'm going to bring down mole of magnesium, and I want to do my mole to mole ratio of magnesium to magnesium oxide. So 2 moles of magnesium to 2 moles of magnesium oxide times, draw a line, bring down mole of magnesium oxide, and now I can go to the periodic table and get the mass of Mg plus O, which is going to be 40.305 is the mass of magnesium plus the oxygen. So now I want to calculate the answer that I get from this, and that's going to get me 2.52 grams of magnesium oxide. That is the theoretical yield of magnesium oxide, and this is the actual yield of magnesium oxide. So now that I have the theoretical and I have the actual, I can calculate the percent yield. The percent is going to equal the actual divided by the theoretical times 100, and that's going to give me my percentage. Now we end up with a very large number, 146%, and that is not a realistic number. However, we did do the math correctly, so this is unrealistic. There must have been a contaminant in my final sample, this one right here, because that's way too big of a mass. This usually should be a smaller mass than the theoretical, because the theoretical is the maximum possible yield that we could have. But I made up numbers in order to do this problem, so it's really my fault. So just to recap, step 1, I subtracted this minus this to get this. Step 2, I subtracted this mass minus the weigh boat in order to get the actual yield. Step 3, I took this mass of magnesium and I calculated how much magnesium oxide was I going to get, and that is my theoretical yield. And then step 4, I calculated the percent yield by taking the actual divided by the theoretical times 100.